a broad variety of machines that power everything from planes to electricity to cars by combining fuel and air and combustion them together to drive something. In the case of cars especially, these tend to use fossil fuels these days to burn, which creates lots of carbon dioxide emissions. They can be optimized for other fuel sources like biofuel or hydrogen, which can be especially promising because hydrogen combustion engines can power heavier duty things like trucks and machinery with the same set inputs as a hydrogen fuel cell. But no matter the input, you still create extreme conditions within the engine that turn nitrogen and oxygen in the air into dangerous nitrogen oxides of various forms called NOx. To get rid of these, traditionally, you run the exhaust through a dense mesh of catalysts, it's like platinum, such called a catalytic converter, that cause that accelerated reaction between the NOx and the air to turn into regular N2 and other outputs like CO2 and H2O. However, the rarity of the metals involved creates ethical dilemmas in mining them, and the slight efficiency loss in the catalytic converters themselves means that if you were to find a more efficient way to break down emissions, it could be a great boon for making cleaner cars, construction, and other machinery.
So to combat some of these environmental problems, we're going to discuss plasma-based catalytic converters. These converters are very similar to traditional catalytic converters in that they break down the harmful chemicals into more neutral chemicals. And doing this, they're going to use a plasma. So to get these reactions to happen, you need to meet something that's called an activation energy. And to do that, you need a lot of energy in your system. But also what plasmas do is they actually change the curve to look more like this. And that way there's a significantly lower energy threshold that you need to meet to initiate the reaction. More than that, plasmas also produce a lot of free radicals, which increase the overall energy of the system anyways, making it even easier to achieve that energy. Because of this, plasmas are much more effective than traditional metal catalysts like platinum and palladium in reducing these emissions and creating a more environmentally safe environment, and despite a lot of energy. James is going to have a little bit more of the specific details.
So these would be the two formulas that we would like to happen to break down nitric oxides, and these will be happening before encountering nitric oxide, because in the exhaust we have oxygen and nitrogen, and they will be broken down and synthesized into either ozone or excited oxygen and excited nitrogen. However, due to the electron breakdown limits, most of the electron flow into the plasma mean energy will fall between 5 to 4, which is extremely efficient in producing ozone. However, excited nitrogen is the one that we need, that will be more efficient in breaking down nitrogen oxides into nitrogen gas and oxygen gas. But however, if we introduce catalysts of carbon and hydrogen with the catalyst of carbon and hydrogen water, it will be easier for that reaction to happen through these two reactions.
To better understand the effectiveness of plasma catalytic converters compared to traditional catalytic converters, we can do an experiment where we first start with the known concentrations of toxins that are produced from the exhaust. And then we can flow that through to a plasma catalytic converter and also flow another known sets through a traditional catalytic converter. We can then take these exhaust outputs and run them through gas analyzers to compare the compounds that come out, and thus we can compare the efficiency between the two, between a plasma catalytic converter and a traditional catalytic converter. These results will help overcome the challenges through increasing efficiency and eventually allowing plasma catalytic converters to overcome the efficiency of traditional ones.